Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of direct variation, specifically how we can use it to solve problems, and we'll do it in 5 minutes or less. So we have a sample problem here, pretty simple and straightforward. The number of cupcakes a baker can make varies directly. So that's our key term. You're going to see something like that in quite a few problems in 8th grade, varies directly. And all that means is it's just signaling that you have a constant rate or a constant proportion. It's very similar to when before we would rate problems, so we would get some type of rated proportion, and then we would always get that phrase, if this rate continues or at this rate. Well, this varies directly is just telling you it's just a constant rate. We actually have a formula which is going to look very familiar for us. This is our direct variation formula, y equals kx. So we know all of these terms here, but let's still go ahead and label them. So everything starts with our independent variable, and so that is going to be our x. Something happens to it. We pass it through this k right here. So this is our constant of proportionality. It's multiplied, so it's either going to get larger or smaller based on whether it's a whole number or a decimal. And then once we get through this constant of proportionality, we wind up with our y, our dependent variable. So the y depends on what happens with this x and this k. So those are the basic terms, and that's something we should be very familiar with. So we have this problem here that varies directly, so we're going to use our direct variation equation right here, y equals kx. So let's take a look at the proportion they're giving us. 20 cupcakes in half an hour. All right, so they don't give it to us, but I'm going to say that my independent variable is my x, so we're going to start with that half an hour, and whatever our constant of proportionality is going to dictate how many cupcakes we can make in that time. So remember, we need our y equals kx. All right, so my x is going to be half an hour. We don't know what my k is going to be. And then we've got our y here, 20 cupcakes. All right, so we've got a little equation there. And if I really kind of wanted to rewrite it, I'd drop the labels. 20 equals, I always put that first, the coefficient first. All right, so 20 equals 1/2 k. How many cupcakes can she make in 150 minutes? Well, I can use this equation, or I can use a proportionality. We'll do both just to show you that they do the same thing. But let's see if we can figure out the constant of proportionality, right? So how do I isolate this k? Well, we know that k equals y over x, right? So let's get that x out of here, that half. So I'm going to multiply both by 2, because 2 times 1/2, right, equals 2 over 2, which equals 1, which makes it disappear. So I just need to multiply both sides by 2. So that's going to let me know that my k equals 40. All right, so that's my constant of proportionality is 40, which makes sense. If I can do 40 in an hour, I can do 20 in half an hour. Okay, so now I need to figure out this 150 minutes, and you notice kind of got a little bit squirrely here. We've got half an hour to 150 minutes. So I'm going to go ahead and change my 150 minutes. Let's see, 1 hour is 60, 2 hours is 120. So that's going to be 2 hours and 30 minutes left. That's 2.5 hours. So that's the only trick there, right? So 2.5 hours. And so now we can do this. My k is 40. My x is 2.5, right? And then so I'm looking for how many cupcakes I can make in that 150 or 2.5 hours. Well, double 40 is going to be 80. Half of 40 is 20, so 80 and 20 makes 100 cupcakes. So there's my solution is 100 cupcakes. Also, we could make a proportion if we want to, right? We can say half an hour for 20 cupcakes. You'd still have to get this 150 into 2.5. And you can figure that out right there. And if you do cross multiplication, you're going to get the same answer of 100.